Welcome back. We're writing Middleman Computer in C++ so that I can learn the language a bit better. And we've completed the computer, we've completed the little man's parsing of a single instruction. So it almost feels like we're very nearly there, and the next logical step, I guess, is to allow multiple instructions to be executed sequentially. So let's see how we are going to do that. Let's pull up our tests and see where we're at. So as you can see here, all of these tests so far have got a single instruction followed by a halt, and we now need to find a way to move forward that allows us to deal with multiple instructions. So I guess the easiest way is to kind of dive in and see where it takes us, and we can always revert back and try a different direction if we don't end up somewhere we like. So little man interpreting input then output instructions. That seems like a logical sequence to play with initially. Instructions results in inbox value transferred to outbox. Let's see what that gives us in terms of directing our coding. So assert r equal doesn't matter 99 computer dot outbox. And we'll create a computer and check that. Did I not write? Okay. So hopefully that just fails straight away, and it does, because we just have random contents at the moment. So now we need our man to run the program. Like so. May vary the output slightly. And indeed it does. So now we can write a little program. So let's put our value in the inbox, and then we'll have a computer, we'll have a little program in our memory with two instructions this time. So just to remind ourselves, the input command is 901, the output command is 902. So we'll essentially have 901 followed by what we would if we'd have typed it correctly, followed by 902 and then a halt. Like so. That looks correct, and we'll see what happens there. I'm expecting it to remain unchanged, yes. So if we look at our computer code, we can see that we're only running a single instruction at the moment. So the simplest way to make this pass, well, there's technically, so we have to make this pass without breaking the other tests. Now, if we were to simply do this, would that do the job? Yes, it would. It's a little bit horrible, but technically it passes the test. And it also doesn't break any of the other tests, I don't believe. I think all the other tests passed, didn't they? So the only tests it would have affected were those that asserted things about the outbox. And in this case, we would so this first test, and in that case we would just be running the output twice in a row, which would have no impact on the results. So that's correct, I guess, in a strict manner. So how can we write a test that would break that? I don't think we could very easily. We can write another. So let's just write another test, because that's fine. That technically passes the test. So if we move to a test, that's say interpreting input then store instructions, results in inbox value transferred to memory. I think that probably progresses us in a direction that we want to go. So assert r equal 11, why not? Memory 62, doesn't really matter. Let's be a bit bold and skip a few steps here of running the tests, as I think we're relatively confident we know what we're doing. Like so, and then the inbox value is going to be 11 this time, and then our first instruction sets the accumulator, and our second instruction is a store, which will be 300 into memory 62, so 362, and then halt. So if we run that test, we should see it fail, as we haven't run the second instruction. That looks sensible. So now how do we pass this test? We could start building up an if-else thing here, but it feels like the simplest way to pass the test in this case is to just duplicate this. And that would also retain the working of the previous test that we had just written. So we can get rid of this instruction. I assume we have to remove these autos, and the only change is to use instruction from memory 1. Now that doesn't work, of course, because I didn't type all of the letters. Does that do what we want it to do? It would be very nice if it did. It does, excellent. So we have a lot of duplication that we've suddenly introduced here. And it feels like we can pull out a little private method there that runs a single instruction with the single parameter of the memory address to run it from. This does, of course, because it's C++, require tinkering with the header file, which is a shame. So, little man down here, we can have a void run instruction with an address like so. That name seems fine for now. And then here we can have void little man run instruction const int address and so on and so forth. Ooh. Copy and pasting is going to be a little annoying there. Let's call that instruction address. Somewhat verbose, but we'll deal with that later. No, don't do that. So, instruction address. Somewhere. And then we should just be able to paste in the instruction like so. Good. We probably want to change this to memory address, don't we? We pull out that and replace address with memory address. Should do the job. Looks good to me. And then this lot we can just change to now to run instruction naught and run instruction 1. At least we could spell. Well, it compiles, that's a good start. Excellent, and everything still passes, and we're moving somewhat in the right direction now. Feels like this should be after this to match the ordering from the header file. Not that I think that matters too much in this instance. Just check everything passes still. Wonderful. Now, if we go back to here, all tests with 2 instructions are going to work fine. If we were to add a test with 3 instructions, then that won't work quite so well. So we shall endeavour to do that. Let us imagine a little 3 instruction program. Thing input, then I guess then we can add, then output perhaps. and we'll see results in input plus value. It's all gone awry. Inbox plus value into outbox. And we can write something sensible here. Let's just imagine we're going to do some relatively large numbers. Let's see if 25 plus 12 or some such is the right answer. And we need a computer. We need a man running. We need a man to do the running. And we need a program. Inbox is, say, 25. And then we need a program which is an input, a load, which is 500 and something, so 504, doesn't really matter. Then we need, oh, if we that's supposed to be add, isn't it? My bad. So add is 100. So add from memory location 4, and then an output, then a halt. Oh, that's not where we put our halts. And then the value 12 to do the adding. So that looks plausible, doesn't it? I don't think I've saved. That looks more promising. And it fails sensibly. That's good. So now we should be able to simply make that pass by doing this in principle. That's good. Now have we come to the point here where we have enough duplication in this run instruction to replace it with a loop? That is the question. Because we're just going to keep... oh, hello. Has that? I'm surprised that hasn't broken any other tests. We've got lucky, I think, by the contents of memory not having caused us difficulty. So we could in principle seed memory on some of the other tests where this third instruction will have something that breaks the test in it. But we've got away with it here, so I think we'll just count ourselves lucky. So what would this look like if we were to refactor this into a loop, which would seem a sensible thing to do? So it would probably look something like auto instruction address equals 0. While computer.memory instruction address, oh, are we going to run into difficulty here, is not equal to 0. Run instruction yes, we are, aren't we? Because that should be program counter. And if we were to do while computer.program counter computer memory computer program counter is not equal to 0, computer.program counter that's not going to do the increment now. Does that do the incrementing in the right order? No. Perhaps not surprising. So that is not a valid refactoring. How can we get to the position where we increment the program counter after extracting the instruction from memory, but before any branches happen? Because the place to put that is sort of in this gap here. Do we have enough confidence in our tests to just do that step immediately? I feel I want to write one more test that checks that after a sequence of instructions, the program counter is in the right place. I feel that would give me a little bit more confidence in where we're going. So, interpreting a sequence of instructions results in the program counter pointing just after the halt. That should be where we end up, I believe. So if we were to just, for example, steal this same test but with a different assertion, we're happy with that. But what we want to do is to make sure that the program counter is pointing. So what will happen is program counter starts at 0. We'll run this instruction and the program counter will be at 1. We'll run this instruction, it'll be at 2. We'll run this instruction, it'll be at 3. And then we'll run this instruction, it'll be at 4. And this will kind of tease out the incrementing. We will have to deal with the halting. But I think that's okay. This should fail in a sensible manner with the program counter staying at 0 all the way through. And indeed it does. It should be relatively straightforward to make it pass. All we need to do is put an increment of the counter here. Like so. And that's going to still fail because we're not running the last halt instruction, but that's okay. We will add that in now. Oh, did that fail more than one test? 4 tests failed here. 4 tests failed. So the branch instructions tests are wrong, aren't they? They are. Let us just temporarily back out this test. And its passing, and rectify the 3 branching tests. So if we look in here, so we have a branch instruction results in the program counter being changed to the address. So this is an unconditional branch that jumps to address 7. So address 7 should be the halt. This is the same to address 8, and this is the same to address 9. So those tests are now correct. So this is going to be a slightly more involved passing of this test, I feel. So that should fail, but just this last test. And it does. So how do we make that pass? So if I uncomment this, that should be fine. But we're going to get some test failures still. Yes, those 4. Why do they fail? I see why they fail. Cheeky. So they fail because of the wonderful whiz he was. They fail because we're not halting properly. So we need a little bit of preemptive refactoring here. So let's go back to our 1 failing test. I could comment it out, but I'm not going to. I'm just going to leave that there and keep an eye on only that failing. And then this should be if memory 1 is not equal to 0. No. Yeah. Got ourselves in a little bit of a corner here, haven't we, with these branching instructions and the program counter. Right. We might just have to take a slightly bigger step here to make this test pass, or think if there's a better test we can have. But so let's back out where we've got to. like so. We should be back to sensibly parsing, and let's commit our position there. Yep. Interpretation of multiple instructions. And I think we'll leave it there and have a bit of a think about it in the interim.